Hi there. The future of AI is AI agents, and at the heart of every powerful AI agent is reinforcement learning. Now, curious on how reinforcement learning actually works, then this video covers the key concepts and walks you through a very practical demo. Now, before we jump in, I will quickly explain the differences between machine learning, generative AI, and agentic AI with a very simple example. It will help you see where reinforcement learning fits and why it matters. Now let's say we have 2 points, a start point and a target point, and you have collected data regarding the time taken to go from start point to the target point. Now using machine learning, you can predict the time taken between the start and the target based on the historical data. And using generative AI, you can take your application to the next level by creating a chatbot which can generate answers to any questions on travel time. Agentic AI goes one step further. It can tell you on how to go from start to the target. So in summary, machine learning predicts a value based on historical data. Generative AI is generating content such as chatbot text answers, and agentic AI is about how to do a task, or in other words, how to get stuff done. At the core of agentic AI is reinforcement learning, which is about making an agent learn about how to do a task. Now let me explain some basic concepts. Let's say we have a 3x3 grid, and we have a starting point which is situated at 0, 0 and a target which is situated at 2, 2. Now this grid is also called as an observation space. Now how can you teach the computer to go from 0, 0 to 2, 2? You can write a program such as if the current position is 0, 0 then go to 1, 1. If the current position is 1, 1 then go to 2, 2. However, such an hard-coded approach will fail if the dimensions of your grid changes. A better approach is to use reinforcement learning. In this approach, we have an agent whose task is to go from start to the target. At any point, it can take 4 actions: left, up, right and down. And we will let the agent take random actions. If the action doesn't make the agent hit the target, we will give agent a penalty of -1. The agent can take actions from its actual location, and this is called as exploitation, or the agent can randomly place itself at a different location, and this is called as exploration. After taking many actions, the agent will learn on how to reach the target. And as soon as the agent reaches the target, we will give it a reward of +10. Now this approach of penalty and reward forms the basis of reinforcement learning. The learning of the agent is captured in something called as a Q table. You can consider the Q table as the agent's memory. This Q table will contain information on what is the optimal action to take for any given location. Now let's see these concepts in action through a demo. We have an observation space such as this 3x3 grid, and we would like to train an agent to go from start to the target. The start is situated at 0, 0 and the target is situated at 2, 2. Let's now train our agent using reinforcement learning. Just a reminder, training agent means performing exploration or exploitation which can result in a penalty or a reward. Alright, our agent is now trained and it has found a path to go from start to the target. The agent training is captured in a Q table which represents the memory of the agent, and here is the visualization of the Q table in form of a heat map. On the y-axis you have each position on the grid, and on the x-axis you have all the actions. And here we have 4 actions: left, up, right and down. And at each position the agent will take the action which is corresponding to the highest value, which is also visualized as a dark red color. So for example, at the position 0, 0, the highest value is represented by the action to go right. And it's for this reason the agent would go right when it is at the position 0, 0. Now if you look at the position 1, 0, the highest value is represented by the action up, which means that the agent would go up when it is at the position 1, 0. Now once we have the agent trained, you can choose any start location and the agent will find its way to the target. So for example, if I position the agent at a point which is not 0, 0, it will still find the path to the target. And this magic happens because of the Q values, which is the agent's memory to find the optimal path. Let's now increase our grid size and let us also put two obstacles. So the grid would look something like this as shown on the screen. Will the agent be able to find its way to the target? Let's find out. Let's once again train our agent, and voila, the agent is successful to reach the target in spite of the obstacles. You can also see from the Q table that agent is trying to avoid the obstacles, and this is shown as a very low value in the Q table for the position and the action which would lead the agent into the obstacle. The Q table will help the agent to reach the target from any position on the grid, and it is going to reach the target by avoiding all the obstacles. So in summary, we have used reinforcement learning to train an agent on how to do a task of going from one place to another. Reinforcement learning is the foundation of agentic AI, which is all about training agents for task automation. And this task could be as simple as what you have seen in this video, but it can be also complex, such as stock market trading or household robot. So hopefully you got some fundamentals of reinforcement learning and why it is important in the era of agentic AI. You can also try out the demo which I have shown you on my website experienceterrascience.com. The link is in the description below. The future is agentic. Are you ready for it?